Is this thing on? Oof, I'm ugly. Shh. Y'all be quiet now. Don't be loud. Okay. Good morning, children. How y'all doing? Okay, I'm going to teach you today a little more about cells. All right, so before we talked about the scientists who invented the cell theory. Okay, so now by the end of class, hopefully you'll understand how materials are transported throughout the cell. Did you hear that? Our objective is that you will understand how materials are transported throughout the cell. Okay, so first thing, can anyone explain what does the prefix trans mean? What you say? Okay. The prefix trans means across. Okay, so we're going to learn how materials are moved across the cell. All right. So what are some things that you transport or carry to and from school each day? Okay. Which of those things require energy? And which of those things do not require any energy? Okay, so when we talk about active and passive transport, okay, one requires energy, the other doesn't, okay? So watch this. Excuse me. Y'all write this down now, okay? Ooh, my line crooked. Active transport, passive transport, okay? So active transport is just what it is. You have to be active, okay? So if you're active, that means you need energy, right? Being active requires energy, okay? So active transport moves substances from an area of low concentration to an area of high concentration using energy. Active transport using energy, okay? There are two processes that occur under active transport. Only two, okay? Write this down. Endocytosis and exocytosis. Okay? Now, endocytosis is the process where a cell takes in a substance by surrounding it within the cell membrane. Okay? Now, exocytosis is the process in which a cell pushes, okay, or releases substances out of the cell. All right. So in passive transport, okay, there is no energy. No energy involved in passive transport. No energy, okay? Now there are three types of passive transport, okay? You have diffusion, facilitated diffusion, and osmosis. Okay, now diffusion is the movement of substances from an area of high concentration to an area of low concentration, okay? The goal with diffusion is to establish equilibrium. Equilibrium, that's a big word, huh? What did that mean? Tell me, what do you think equilibrium means? Equilibrium just means equal on both sides. Well, both sides of what? We want equilibrium on both sides of the cell membrane. And you'll see in just a minute, okay? Now, facilitated diffusion is just like regular diffusion, except it uses a little bit of help from what is called transport proteins, okay? And we'll talk a little bit more about that later. Now, osmosis is a diffusion of water, okay? Remember that high to low concentration, but of water, okay? So again, osmosis is the diffusion of water. Now, remember we said we want to establish equilibrium, okay, on both sides of the cell membrane. So, a cell membrane, okay, is actually what's called semi-permeable, okay? Semi-permeable membrane. Well, what does semi-permeable mean? What is that? Anybody can tell me? You right here, sir. You tell me. Well, semi-permeable means, okay, well, I'll tell you what. Think of when your mom cooks some ground meat, okay? When you drain the grease in a strainer, okay, what are some things that are allowed to come through the strainer? The grease, okay? But what is too big to pass through the strainer? The ground meat, right? All right. So when you think of a semi-permeable membrane, okay, think of a strainer, all right? Now, semi-permeable means it only allows certain material to enter or leave the cell, okay? Only certain material, all right? So today we're going to focus on passive transport, okay? Now, we'll focus on active transport tomorrow, okay? So, now we're going to do a mini lab, okay? Don't get too excited. On the role of the cell membrane, okay? Now, here's a list of your group members. No whining now, okay? The name in bold is the group leader who will be responsible for collecting the materials as well as the cleanup. All right, let's get started.